Hi, it's Sean from NewPave, and today I've got a little bit of a longer video for you. What I'm going to do is I'm going to take you through the crack repair that I've put the shorts up for. And I'm going to slow it down a little bit, and I'm going to give a little bit more information on the products that I've used and the reason I've used the method that I have to stabilize this crack. So yeah, let's get into it. When repairing structural concrete cracks, the goal isn't just hiding the crack. It is to stabilize movement and reduce the chance of the slab continuing to separate over time. The first step in this repair was chasing the crack. By opening the crack up, we can properly remove loose material, clean it out, and allow the repair products to penetrate and bond correctly instead of just sitting on the surface. After that, we cut cross stitches across the crack at intervals. These act like reinforcement bridges between both sides of the slab. These channels will later be used for the structural side of this repair. One thing people often get wrong with crack repair is making the repair too rigid at the surface. Concrete expands, contracts, and moves with temperature and moisture changes, especially here in Melbourne. If the surface becomes harder than the surrounding slab, the concrete can simply crack next to the repair instead. That's why we use different materials in different parts of the repair, depending on what the slab is doing and the finish going over the top. No crack repair can honestly be called guaranteed to never crack because we can't control ground movement or the original slab design. What we can do is use methods to help stabilize the slab properly and give the resurfacing system the best foundation possible moving forward. Now for the structural side of this repair. Once the cross stitches were cut, we cleaned them out thoroughly to remove dust and loose material. This part is important because the repair is only as strong as the bond underneath it. We then used Chemset 801 as the structural adhesive within the stitch. Chemset 801 is designed to achieve extremely high bond strength and is commonly used for anchoring threaded rod and structural fixings into concrete. In this repair, its role is to lock the galvanized steel reinforcement into the slab itself. After the 801 was injected into the stitch, galvanized threaded steel rods were inserted across the crack lines. What this does is mechanically tie both sides of the slab together beneath the surface. Instead of the crack acting as two independent sections of concrete moving separately, the steel helps distribute load and reduce independent movement between both sides. The important part here is that the structural support is happening below the surface, not just the top where you can see it. Surface fillers alone may cosmetically hide a crack, but they often don't address the underlying movement that caused the issue in the first place. At the same time, we also need to avoid what is called creating a hard point. If the repair becomes too rigid compared to the surrounding slab, movement and stress can simply transfer next to the repair and create another crack beside it. So this repair is designed to work together as a system. Structural support beneath the surface through the steel and Chemset 801, while the upper repair layers are chosen to work more naturally with the expansion and contraction of the existing concrete. Once the structural side of the repair was completed, we used Dulux Avista patch repair over the top of the crack and stitch areas. This product is designed for concrete repairs and dries to a very high compressive strength, around 60 MPa, making it suitable for heavy duty applications. But strength alone isn't the goal. The way the repair is applied also matters. In this case, the patch repair was feathered out beyond the crack itself to help distribute stress more gradually through the slab rather than concentrating pressure directly along the repair line. Another reason we use this type of repair mortar is because it behaves more similar to concrete than a completely rigid epoxy fill. Once the patch repair had cured, we then applied a squeegee coat across the entire surface. The purpose of this coat is to help create a more uniform substrate before the resurfacing system goes down. Rather than only treating the crack itself, the squeegee coat helps blend repaired areas into the surrounding concrete and reduces visible transition lines between old and new surfaces. It also helps fill minor surface imperfections like pinholes, low spots that can show through decorative finishes later. In resurfacing systems, preparation is a huge part of the finished result. The decorative coatings are only as good as the surface underneath them, so this stage is about creating consistency across the slab before moving into the final texture and finish coats. The goal isn't just appearance, it's building a surface system that works together from the concrete preparation right through to the final sealed finish.